Hope you guys ready for our lecture. Right. Okay. Hi, Noel. Right. So I'm gonna start recording. Okay. So today we're gonna talk about 2.0 topics. Continue from yesterday, right? And then we'll see how much further we can go on the land security after that. Okay. Right. So EIGRP is our topic. Let's have a look. Okay. So uh, the first section. Today we're going to talk about the characteristics. What is this EIGRP? So you've seen yesterday there are quite a few number of protocols that is being used on the router. Okay, RIP, OSPF, and EIGRP. So we're going to look at EIGRP for the rest of the chapter, and we'll start with finding out what is this EIGRP. So characteristics of it. What's the features of EIGRP, right? And after that, the second section is the implementation part, right? So when we go to the router, how do we implement this EIGRP by configuring our um, routers, yeah? And then we verify our configuration, right? So let's start with the, right? Oh, sorry, yeah. And also, we'll look at the operation side of EIGRP. So we have already seen metrics being utilized yesterday, right? So we'll go into more details about the operations side of EIGRP. Yeah? Right. So let's go to EIGRP characteristics, starting with basic features. Right. So what is this EIGRP? So IGRP is basically a classful um, protocol, right? And Cisco took that and modified it so it becomes a classless version, right? And this is Cisco's proprietary implementation. Okay, so EIGRP or enhanced IGRP is a distant vector routing protocol. It was released 1992, so quite some time ago already, yeah, right? And it's basically work on IP version 4, right? So where do we use EIGRP? We use it in a large, that means simple network with maybe one or two routers, maybe don't have to do any of these protocols because we can perform our own manual configuration or static configuration, right? So, but once your network become large, right, and there's a mixture of protocols used in those routers, then EIGRP will be a good protocol to use, right? So, what features can we see under EIGRP, right? Yesterday during tutorial, Kelvin was looking at one aspect only, right? And the reason why you can't really answer correctly that question, Kelvin, is because we haven't touched on other aspect of EIGRP, right? We only look at one aspect only yesterday, right? So these are the features, other features, right? So the first one is diffusing update algorithm, or in short, it's called dual, right? It's an acronym, right? So this we don't really look at dual in that much detail. That means we don't look at the we don't have to look at the algorithm itself how it works. Yeah, suffice to say that it is a routing algorithm, right? And if you use dual as a routing algorithm, which is what a EIGRP is using, yeah. So this algorithm allows loop free, right? That means it prevents the way it set up the routing, it prevents any loop from forming. We already mentioned that there is a feature inside IP version 4, the TTL, where errant packets can be dropped, okay, after going around in the internet network for a number of time. By the time the TTL value goes down to 0, then it will be dropped, right? Now, dual complements that. Dual, basically, in terms of the routing algorithm, if the router implements it, right? So the algorithm prevents loop from happening in the first place. Okay, try to provide the routing that that do not form a loop, right? And dual also, but at the same time, dual allow to have backup path. That means allows traffic to not be limited to a single path. So if you have multiple paths inside your network to reach the certain destination, then dual allow you to make full use of the alternate path. So uh, able to provide backup path, okay, throughout your routing domain, which is where the size of the internet network that you allow traffic to flow. Right, so that's dual, okay, and it's because Eigrp implements it, so it's part of Eigrp feature. Right, establishing neighbor adjacency. This simply means if you have identified routers that you want to talk to each other, right? So the routers need to know which neighboring routers it is able to exchange information with. So using Eigrp can allow a router to establish relationship, right, with directly connected Eigrp routers. So routers in its surrounding area, right? Usually directly connected routers are one hop away only. Okay, one hop away, right? So forming adjacencies allow allow the routers to be able to keep track of the status. Status means the information that's belonging to the uh, other neighboring routers, lah, right? That means when we talk about exchanging routing table information, right? So in order to allow this, adjacencies are created, right? And then so those routers that is adjacent to each other, right, just one hop away, will then exchange information using Eigrp, right? Thirdly, a reliable transport protocol. So there is a protocol called RTP, right, that is used by Eigrp. This one, we already mentioned about layer 4, yeah, layer 4 in the network OSI layer, and also the CPIP protocol layer, where transport layer allows you to have reliable transport. So this RTP is an implementation that is reliable, meaning if you send any messages, then you require acknowledgement on receipt, right? So this is the implementation RTP, okay, used by Eigrp, okay, so that it's ensure the packets, the Eigrp packets that it sends to the other routers is actually received, right? Right. So this RTP and the adjacencies is part of the requirement to be used by dual in order for it to be able to create this routing algorithm. Right. So fourth one is partial and bounded updates. Okay. So when we say updates means how often do the routers send information to each other, right? So using partial and bounded updates is different from periodic updates. Periodic updates simply means using based on a timer, right? And you specify the elapsed time of the timer. When it elapses, then you send an update, and then timer reset. That is periodic updates, right? For Eigrp sends partial triggered updates. Okay, and it's sent when it detects a path or any metric has changed, right? So this is done to minimize bandwidth usage, right? Because if you keep doing periodic updates, and basically every router will do the update, right? not only one router. So you'll find that the path between routers will be utilized by these, updates, right? And it takes up the bandwidth. So instead of doing periodic, only update if there's any changes, right? That means path changes means topology change, right? A path have become is added, or manually added by the administrator, maybe change the topology, so the path change, or one of the path or more has gone down, right? Or any metrics change. That means the path still available, but maybe changes in what kind of metrics, whatever protocol you use, what kind of metrics you use. So if you think about bandwidth, suddenly you change cable, change port, right, to use a slower or faster bandwidth, then metric change. If you're using RIP, for example, if you allow IRP to win, then you add another hop, then the metric changes. So if there is any change in the topology, thereby the path, okay, and then changes in the metric calculation, right, then only there's a change in the information, right? Change in the way that the choice of path to be inserted into or removed from the router's routing table. So if there's any changes to the routing table, then an update is sent out. Okay. So if there's no changes, there's no need to send an update. Periodic updates means even there's no change because you're based on a timer, you still send out, right? The router still send out, and this is the taking up a bandwidth. So to eliminate that or reduce that, then only when there's a change, then the router will send the updated information. Only the updated information, not the full. So that's why it's partial, right? Partial. Right. Finally, number 5, equal and unequal cost load balancing. So remember we talked about um, if the RIP or SPF, right? The way they update their routing table is that the winning path will be inserted there. So from then on, any forwarding choices or decision will go to that particular winning path, right? But Eigrp has a feature where not only that it do load balancing, okay, load balancing for path that equal in terms of cost. Remember, we choose a path based on lower cost. But if we have equal, then a capable protocol will be able to balance the load. That means send 50% packets there. They try to balance it out, 50% packet there. But this Eigrp also work on load balancing for unequal cost path, right? So uh, it considers if there is a path, even those paths are not equally in the sense of the metric cost, then it'll still do the load balancing. And this is good because you can relieve the traffic on the main path, so that some other path, alternate path, can take up some of the traffic, right? So that means your network is allowed to self organize in such a way that to reduce traffic lah, right? Um, Instead of just one popular or winning path becoming congested, then we allow the traffic to go through alternate path, even though maybe the cost is higher, right? Okay, right. So Eigrp uses protocol dependent modules called PDMs, right? So because the usually these protocols are, for example, layer 3 protocols like IPv4, IPv6, and other legacy protocols, IPX come from NetWare. NetWare company, but they are legacy because most companies do not use them anymore. But just in case, okay, just in case some companies still use these legacy protocols, right? Like IPX and Apple Talk. Okay, so open standards like IPv4, IPv6 uh, considered the winner in the protocol wars. So most systems now use IPv4, IPv6. Nevertheless, both IPv4 and IPv6 they are not compatible, right? Um, that's why last time we talked about the transition between IPv4 and IPv6. We have to use something like tunneling or translation, all these things, right? It's because they are not compatible. So in order to use both and to be able to do to support both, Ergrp also have to use multiple type of PDMs. Okay, each PDM will be supporting different protocols. So you have a PDM for IPv4, PDM for IPv6. You can see here, right? In this example, right? So you can see the neighbor table for IPv6, neighbor table for IPv4. We only look at these two because you can, if you support IPX and IPtalk, if there's a need to support it in the network, right? Let's say part of your network still using IPX, for example, then you will see additional PDM here, which is uh, geared for using IPX, right? So these PDMs they are each PDM to support an individual protocol. They're not compatible, so that's why we have one PDM for each. Well, the PDMs are used to maintain neighbor and topology tables, right? When you send, right, when you send packets between, right, between routers. So if your network is IPv4 and you enable IPv4, then IPv4 PDM is used. But let's say you use IPv6 and IPv6 is used. If you use both, right, you're able to, you want the network to be able to transport both IPv4, IPv6, then you will use both, right, IPv4 and IPv6, right? So because they're not compatible, so everything has to be duplicated, right? So that's why the multiple protocol dependent modules are needed. So neighbor and topology tables, there will be one for IPv4, there will be one for IPv6, for example, right? Computing metric using dual also requires these PDMs. Interfacing dual the algorithm with the routing table, implementing filtering access list. This one is security. Filtering means you allow which traffic from which computer to be transported in the network, right? Access list also ACLs. I think in this, not sure whether this course has that, but if I have to have a look at our syllabus. But yes, one of the things that you will learn is how to create access lists. Access list is to filter what protocol you allow to transport inside your network, right? And which from which IP address. So access control is basically it's a way to secure the network by allowing or disallowing which traffic from which IP address and what kind of traffic flows allows to flow through the network, right? So implementing filtering access list, of course, because IPv4, IPv6 are two different protocols. So PDMs that handle this also need to be um, separated, right? And finally, performing redistribution with other routing protocols, right? So these are the basic feature. Okay, so far we look at and one we mentioned just now, operating on the transport layer, is called RTP, right? You can see it's layer 4 internet layer, where we talk about the version 4, version 6 internet protocol is layer 3, but this is where the router works, right? And because we already know about the protocol stack, that if you want reliable transport, the internet layer is the best best effort, right? Best effort. You cannot implement reliable transport on the layer 3. Okay, so if you want to implement reliable transport of packets between routers, okay, in order to exchange information, probably using Ergrp, then you have to have your own transport protocol. So the ones that used by Ergrp is called RTP, right? So you can see it's used for delivery and receive or reception of the Ergrp packets. All right. All right. So there are a few things that these are the content of the transport protocol, RTP. You have update, query, and reply, right? And acknowledge, right? So unreliable packets, we don't need to have acknowledgement, but if you want to have reliable transport, means you want to ensure the packet is actually received by the intended recipient, then you must wait for the acknowledgement, right? So we've learned about TCP before, right? TCP is um, a transport protocol for normal communication, okay, used by your application, right? TCP, and then UDP is unreliable. Okay, so Ergrp needs its own protocol for the Ergrp packets. Okay, so to be reliable, then of course it will be implemented in transport layer, right? And but the idea still was the same. Okay, if you send a packet, let's say Ergrp packets, then the router expect an acknowledgement, right? Okay, so is it okay so far?
Okay.
Okay.
All right. So we move on. Right. So this is another security, the authentication, right? And that means Ergrp has within it authentication, right? And you are recommended to use the authentication, right? Right. That means authentication is this one is very similar to when you log in. Okay, when you log in, your challenge for your username and your password, right? And when you can supply both, okay, then it's seen as you are who you say you are and you're authenticated, right? So this, because the name here is used, keyword is used as authentication. That means it should work with the same concept. So that means when a router needs to communicate, right? Communicate with another router in terms of maybe well, they communicate by sending Eigrp packets to each other, right? So in order for for a router to be able to do this, if you set the authentication, then it needs to be able to authenticate, right? So you can see here, right? That means configuration wise for Eigrp is one of it is to configure a password, right? Or some form of authentication information, right? So if the recipient has got uh, uh, cannot authenticate, means it's not a valid router, then the information will not be able to, will not be sent, right? Will not be sent. Now, please realize that there is no encryption. So that means whatever passes between the routers are not encrypted. Yet, the very simple authentication where, oh sorry, security, whereby we see that the use of authentication using password is applied. Okay, right. So if this is to prevent someone just adding another router and then trying to configure Eigrp to get routing information, right? And then suddenly, from routing information, you basically can build up an idea of what is the topology of the network. Imagine in the real life situation, okay, you cannot see the network, right? The topology, because we are used to using packet tracer, with packet tracer, you can visualize how the topology looks like. In a real world, if you go enter the building, you have no idea what is the topology, right? Okay, so the information about your network topology is the first thing that you need to know if you want to attack a network. What kind of topology they have, what kind of intermediate device, what kind of host, what kind of network address, and inside the router routing table, you got this. You got the network, and also not only for the directly connected info, but also the remote networks. So by using this information, an attacker will have a pretty good idea what the topology looks like, right? So this one prohibit that, although it's simplistic, but it's actually quite effective to stop if a basic attack lah. You insert a router plug-in. If you have access to the to the infrastructure, kan? Then if you enable the Eigrp without authentication, suddenly you will start to receive, all this Eigrp information from other routers. Then you can then build up a topology, right? And from then on, you can do more attacks. So authentication means if you don't know the password, you try to connect and try to receive. Sometimes we talk about routers, but please remember, an end device can be configured as a router, right? A lot of people is using Linux and then install as server services. They can actually run a router service inside their Linux computer. So not necessarily you're using a router to enable all this feature, okay? Because router works on layer 3. So a computer, right, works until up to layer 7. So you can emulate all the layers services. So an attacker can just pretend that this is a router attached, and then receive Eigrp information, can get all the information about the topology of the network. So this one, although it's simplistic, but without the password, it makes it harder. Okay, harder for the attacker to receive all the routing information, right? Okay, so far okay, guys?
Oh yeah.
Yeah.
Okay, all right. Right, so packet types. Just now we have to briefly look at it. The packet types basically are what kind of packets can be sent between the routers. So there are 5 types, right? So the first packet type is hello, to discover other. This one is the router reply. Then means you discovered that router, right? So you know already. I send a hello, a router reply. Oh, I know that router exists already. Okay, so this is basically discovery packet. Next one is update. This one brings with it the routing table information. You can see there, convey routing info to known destination. Right? Acknowledgement is the acknowledgement because remember we have a RTP, right? So there will be a packet that is containing acknowledgement info, right? This is the one that the router needs. After it sends a packet, they expect acknowledgement, then they will receive acknowledgement packet, right? Query is a way for a router to ask another router. Okay, this kind of packet you can is a query packet. Then you can insert a specific request, okay, for specific info, okay, from a neighbor router, right? And then of course, if there's a question, there's a reply, right? So the reply basically means if the router has that information and send back the information, that is a reply packet. All right, so these are the 5 packets. Right. If you guys need further info or not sure about something, just let me know. Yeah. So you can see here we talk about hello packets earlier on, right? Used to discover adjacency. That means you use it to discover what are the routers, or how many routers that is directly connected to you, right? All right. So and then, of course, if you have, and then the router replies, then you can then form adjacency, okay, with each other. You are basically adjacency means you are beside each other, okay? Just beside you, adjacent to you, right? So hello packets, because it's unknown, is a way to find out, right? You can't expect to. You don't expect also because you don't know, right? You don't know yet. You haven't formed adjacency with the router. Okay, it's not part of your adjacency table yet because you just it's a finding out mission, right? The router is figuring out, is there any router adjacent to me? Send out the hello packets. Since you are not sure, right, if there is any router and any router that is willing to set up adjacency with you, then you do not require acknowledgement for the hello packet, right? Not necessarily. Right. So Ergrp, this is in red. So this is means important. Okay. So Ergrp in its communication uses multicast and unicast. So it doesn't use broadcast. Okay. Why? Because broadcast is one to all, right? And routers not supposed to use broadcast because imagine there are so many routers and connects so many networks, right? And you are basically, if you broadcast, the message is supposed to be one to all, so one to all routers. So we don't want that. It will propagate. Broadcast will propagate. So for example, from R1 it goes to R2, and from R2 it goes to any other routers. So broadcast, right? Broadcast. So we don't use broadcast. Okay, broadcast only. Uh, Broadcast domain only within a network itself. So that means you can see here broadcast domain is here, right? So especially inside your network, we consider broadcast inside a network, right? So but for Ergrp, remember it goes to R2. R2 also goes to its adjacent. It only stops when the adjacent router do not want to form adjacency with you, right? That means, let's say the next you're an edge router, so the next router will be someone else's router. So there's no agreement between your two networks. So maybe they don't want to exchange information, right? So uh, multicast means only routers that form adjacency with you. So now you know, okay, there are two routers forming adjacency with me, so they're part of our local multicast group. So if I send out, I just send to these two, for example. Or unicast, for example, for hello, I send unicast, right? I know I have two interface, okay? So let me find out, send hello here, send hello here, right? So this is unicast, this is unicast, right? One packet goes here, one packet goes here. Multicast means the packet goes to both, right? Using example, having same routing table info, for example, right? So these are the two addresses that's being used by the router. For multicast, the IPv4 address is this 224.0.0.10, and for multicast is this FF02, and lots of zeros in between. Yeah, remember last time we learned about how to compress IPv6 address. So colon simply means there's a lot of zeros in here, right? So FF02 colon A, right, is the multicast IPv6 address for Eigrp purpose, right? So update, propagate routing information. Remember, the main purpose is so that I know the other adjacent router directly connected networks. To me, those networks are remote networks. I have no idea. So I'm hoping, let's say I'm R2 I'm hoping R2 can tell me what are the R2's directly connected network, and therefore it is my remote network. So I have an idea of that remote networks to help me, okay, to update my routing table. So at least I know if I receive a packet, right? And when I search through my routing table and it happens to, okay, the network is somewhere after the first hop, then I will forward to this first hop, right? So this update packets, the one that we talk about sharing the information about the routing table, right? Of course, each of the routers that have adjacency with each other will send their own routing table, share their own routing table, right? Sharing this one is reliable transport, so requires acknowledgement. Okay, right? So the acknowledgement sent back by the receiver are dataless because there's no other information just to say that, okay, I acknowledge, I receive what you sent to me. Okay, right. So acknowledgement is used to acknowledge update packets, query packets, and reply packets. Hello packets, there's no need for acknowledgement because you're finding out, right? You're finding out. So maybe there is, maybe there's not. In this case that I'm not talking about there's a router or not. There's a router that willing to form adjacency with you, right? And maybe not. So you're not sure whether they're going to reply or not. So that's why for hello packets, there's no acknowledgement. But once you form adjacency, you know they are supposed to exchange info with you. So that's why update, query, and reply needs acknowledgement. So you want to make sure they receive the information. Right? So query and reply packets are used by dual when searching for networks. They both use reliable delivery and therefore require acknowledgement. And both can use multicast or unicast, right? But replies are always unicast. Why? Because you can send a query, whichever the router that is able to answer. Okay, so you send to multiple routers. But router is not going to reply to multiple, right? Remember multicast, one to many. So reply cannot be one to many, right? Reply will be one to one. Is that okay, guys?
Yeah.
Yeah. Okay, so that's why we know that reply always unicast. Why it's always unicast, right? Okay, so let's have a look at the next section, which is implementation, right? So this is further on from your basic configuration for router. Okay, so you've learned already how to implement basic configuration, right, for routers. Not that difficult because it's very similar to configuration for switches. The only thing is you enable the routing. I think that's one command, right? So now we want to be able to configure the router so that it can get information about, and also forming adjacency with allowed routers so they can exchange their routing table. Okay. Right. So routers usually have a starting configuration that you've done before. That includes address that you set for their interfaces, right? Okay, so that's the case here, right? So you have routers and the basic settings you already make, like routing host name all this, right? Configuring all the interface, bringing them up, putting IPv4 addresses on them, right? Okay, so then the next step will be to set up the routing, right? So imagine that you have done the basic configuration, but you have not done anything about routing yet, right? But before it's one router to one router, so you can just configure static routing. But imagine in this example, you haven't set any static routing or enable any dynamic routing. Okay, right? So just this is the configuration, right? So without the routing, it doesn't have a routing table, so it will not know how to forward. So of course, the next step which is to set up the routing table, is quite important, right? So far, I think the most you've done is to configure the static routing, right? For example, if R1 want to go to that network, okay, the next routing, next interface, next routing interface is this part, right? So you can forward to that, right? And then then the means you also can configure this. If this is attached directly to the LAN, then you just configure the opposite routing, go to here, right? Okay, so before we continue with configuration Eigrp, okay, we need to talk about this something called autonomous system, or simply called AS. From now on, I think they're not going to call it autonomous system. They're going to use the acronym AS, so please remember. But what is this autonomous system? Autonomous comes from autonomy, means you are in charge of it. You are in charge of something. Okay, you don't rely on anybody else to look after it. So that means autonomous system here means a collection of networks that's under your organization, under your what lah. That means you are the one in charge of all this, in charge of this topology, these networks. Okay, it's a way for us to set boundary, because imagine networks connected together, and they combine until they become internet. But of course, when you talk, who is in charge of the internet? No one. No one and everyone, because no one have absolute control over all the networks. But everyone has their own network that they can control, and they form larger networks by agreeing with another, between one set of networks to another set of networks. Administrator say, okay, I agree to connect our networks, right? So that means there's a boundary, right? So that boundary is called an autonomous system, right? So sometimes when you have agreement, right, between two separate organization network, right, then you need to able to exchange routing into between. That means you want to provide routing between your two separate networks. Networks means maybe large multiple networks inside, right? So AS numbers, right, are needed to exchange routes between autonomous systems, right? And then these AS numbers are managed by IANA. So it's something that this organization, this is a global organization, right? And it's assigned to regional, and also to ISPs, right? Because ISPs, they maintain their own network. When you think about your organization, your business, and you as home users, actually you are part of the ISPs networks, right? And all the ISPs belong to RIR. Okay, and then between continent or between regions, usually the region controlled by the regional is based on continent. That we have Asia Pacific, we have Europe, AfricNet, and then you have the Americas, right? So so imagine that we are allowed to connect and all these networks together to form larger networks until it becomes a global internet, right? So these each of these autonomous system is identified by their AS numbers, right? So which are the authority that gives these AS numbers or assign these AS numbers is IANA, right? IANA, this acronym also, right? And then given to regionals, internet, ISPs, backbone providers of telecommunication companies, or large institution, right? And they all connect to each other using AS numbers. Okay, so this AS numbers is 16-bit, ranging from 0 to well, you know that, right? 16-bit numbers, 2 to the power 16 gives you 655T36. So that means the range can be stored there is between 0 to 65535. Okay, in decimal. Okay, you're going to find out. You can 2 power 16, right? So, right. So since 2007, the AS numbers have been upgraded. So because I think it's too small, too prohibition, right? Only this number of AS cannot be, right? So we expand it to 32 bits. That means 2 power 32, approximately 4 billion, right? The numbers are now ranging approximately up to 4 billion. You can do for more accurate value, just do a 2 to the power 32 bits, then you get the actual value. Okay. Right. So why we need the AS? Because your group of routers that form adjacency to each other is actually represent your autonomous systems, right? Right. This one, autonomous system, is actually delineated by your routers, because your router connect to network. So your router indicates how many networks you have, right? So the boundary, okay, the boundary is actually indicated by your networks connected to your routers. So when your router connect to other routers, which is outside your boundary, so this one is your edge router, right? So in order for these two to talk, this is the other organization edge router. So in order for them to talk using BGP, right, they need to use this AS number, provided by IANA, right? So the reason why your own network does not have this, because as I said before, your home network or your company network belongs lah, right? Not physically, literally belongs, but it's formed part of the ISP network. So let's say you go with Unify. So when you connect to Unify, you become part of Unify network. You guys get this, yeah?
Oh, yeah.
Yeah, right. Okay. So we are talking about large networks now. Large networks that requires an AS number, right? Okay. So to configure Eigrp, remember, means all the router belongs to you, forms your autonomous system, right? So you have to specify which router is yours. You give it the AS number value, right? So that means if all your routers, you have to give this AS value. So that means that belongs to your autonomous system, right? So AS function as a process ID, like identifying number. AS number used for Eigrp configuration only significant to Eigrp routing domain. So all routers within your Eigrp routing domain must use the same AS number. Makes sense, yeah? So other people's routers belong to their own AS. So they will use their own AS number. So then we can then differentiate, okay, our networks represented by our routers with other people's network represented by their own network. Okay, their routers have their own AS number. Our routers will have our own AS numbers. Right? Do not configure multiple instances of Eigrp on the same router. Meaning to say, you can have multiple instances. That means more than one instance of your Eigrp. Because if you set multiple, then that means you are duplicating. That means you're going into territory where it's possible to two ERGRP on the same router, one having a different AS, and that is not that's basically not how AS is supposed to be used. Okay, it's misconfiguration lah. Right. So configure ERGRP with IP version 4. The ERGRP router ID is used to uniquely identify each router within your ERGRP routing domain. Okay, so routers will use 3 criteria to determine the router ID. Use the address configured ERGRP router ID, which is IP version 4 address router config command, right? In the next slide, you'll see the commands. Use the if the router ID is not configured, choose the highest IP version 4 address of any of its loopback interface. So, for example, this is loopback interface. This is loopback interface. Loopback interface. Okay. Right. If no loopback interface are configured, choose the highest active IP version 4 address of any of its physical interfaces. So, in terms of value, of course, IP version 4 is unique, so there will always be a highest value address. Okay, so that will be the router ID. So, for example, in router 1, okay, so we use the address configured. What's the address configured? If not configured, then choose the highest IP version 4 address. So highest is just 0.1, 0.1, 0.5, right? So 192, because it includes not only host number here, but also the address number, right? In order to see which is the highest IP version 4 address, right? Okay, so if no loopback, choose the highest active IP version at any of its physical interfaces, right? So here router ID is 192.168.10.5. Here 209. I think this one wins is higher value, 209. Okay, here it falls down to 172, 192, and 172. So 192 wins, yeah. Okay, so it's 0.5. Okay, 192, 168.5 wins. Here 192, 192, 168, 10, 4, 10, 4.6. And here is 0.10, here 0.1, right? So 0.10 wins, okay, higher. Okay, it becomes router ID for that. Now, configure, right? You can see here, you can specify router 1, router 2 here, two different. So router ERGRP1, router ERGRP1, okay? And then you can provide your own. This is the first one, right here. This is you configure. If you don't configure, then this one will be looked at. If this one, well, this one will be looked at. So here you configure yourself. ERGRP router ID 11111 for router 1. For router 2, you configure as ERGRP router ID 2222. So AS is 1. So they belong to the same AS. But to identify the router, you specify the ID. Okay? Right? So how do you, this is the configure. How do you find out what is the router ID? It's type show IP protocols, right? Routing protocol is shown as ERGRP1, 1 being the AS number. Then look under ERGRP here, router ID 11111. Okay.
Okay.
Yes. Any questions? No.
Okay.
Okay. Right. Okay. Right. Okay. Use the network. The network number wildcard mask. Okay. Wildcard mask is not the same as subnet mask. Okay. In the next slide, we'll show you how to come up with the wildcard mask. Although it does well in the using a rough view, it seems like wildcard mask is same as subnet mask, but it's actually different. Subnet mask, we'll just recall first, subnet mask is to tell us how many bits for network portion, how many bits for host portion, right? So we look at the next slide to find out what is wildcard mask, right? So why we need to do that? Because we need to provide this, right? We want to enable and advertise the network in Eigrp, okay? Right, so meaning to say, with this command, we are enabling interface that configured for that network address to begin transmitting and receiving Eigrp updates to start the Eigrp based protocol on the particular router to start sending hello, and then if adjacency is formed, because the other one also you enable, then they will start exchanging info, right? So we need to do this in this command, right? So okay, so let's check the wildcard, right? So what is a wildcard mask? Okay, it does look similar to subnet, but it's different. Okay, so what we are doing is actually doing a subtraction. Okay, so just give you an example. So subnet mask is this, right? And then we subtract it from the 255.255.255. So let's say the subnet mask of the network address is 255.255.255.252, right? So minus that subnet mask value from 255.255.255, you get 0003. So that becomes your wildcard mask. Okay. All right. So if you don't want to configure like that, you can also configure this way. Just put in the subnet mask. Then there's an internal calculator inside your router. Okay. If you don't want to do it manually yourself, the Ergrp will convert it. There's an internal calculator to do it for you. So let's say I say, oh, I don't want to calculate. So just type in the subnet mask. Right, but actually it requires wildcard mask. Okay, then later when you see, it's automatically provided already. You type that 255.255.252, but what you see later when you look at it, like in here, you'll see that it's a save as 0003, same as that. Okay, so the first is this. Let's say you know how to do it yourself, so you put your wildcard mask yourself. Or you can't be bothered, you type in subnet mask instead, but when you look at it, right, so you show running config under section Eigrp filtered to Eigrp, then you start to see it's showing the wildcard mask, not the subnet mask you entered, because it actually calculates for you and store the wildcard mask correctly, right? Okay, so passive interfaces means you don't want the interface, the means because router connect to other router, so you know all the interface that connect to router, you want to enable Eigrp. But you also know that some interface from your router does not go to another router. It goes to where? To switch, right? Because it forms a LAN. Correct? Yeah? Possible, right? Well, not only possible, but it's some interface on the router connect to other routers, correct?
Yeah.
Yeah, but there will be other interface connect to switch because it forms a LAN, correct? Yeah? Yeah. So for those interface that connects to switch means, because that is a switch, so there's no Eigrp, there's no point, right? So for that interface, you can prevent Eigrp updates, right? So you can use passive interface, right? For that interface that you don't want Ergrp updates to occur. So because you can think of, let's say you know that the other side of the router is not belong to you. So that router, I don't want to exchange Ergrp because we did not have any agreement. That's one possibility. Another possibility is that this interface doesn't go to any router, it goes to a switch, because this part of the router, this interface part of the router, actually connects directly to a network. Yeah, a local area network with switch and host. So there is no need to also send Ergrp update towards this interface, right? Whether it's the first reason or the second reason, you can disable Ergrp on that particular router interface by using this passive interface, okay? Passive interface command, right? Okay, so this continue the what lah, right? Continue to another configuration to do for a passive interface, right? So that means both situation where the router connects to another router, but you don't want them to talk to each other, then that interface you set passive. Or the router interface go to directly to a LAN already, a local area network. Then there's no router, right? There's a switch. So you can also specify passive interface. Or else, if you allow, you will see Ergrp messages flowing. Okay, passive simply stops it, right? There's no Ergrp updates on that particular interface. All right, so let's look at verifying Ergrp with IPv4, right? So use this command, show IP Ergrp neighbors command to view the neighbor table, right? And verify that the Ergrp has established agency with its neighbor, right? That means the router next to your router is basically in adjacent to you. It means they are exchanging, right? Their routing table. So when you type show IP Ergrp neighbors, then it will show you all the interfaces that is involved with adjacency. Okay, for forming adjacency with neighbor routers using Ergrp, right? So you can see this is these two are the interface on your router one, and they are accepting or receiving Ergrp hello packets, right? And these are the neighbor's IPv4 address. There, it means your neighbor router's interface address. Okay. So far, okay. Yeah. So you know that your router one is forming agency with two other routers via these two interfaces, and the address is this, right? Neighbor's IPv4 address at their end, right? So when you see this is how you tell whether you have your router successfully create agency with the other router. Okay, so here we see that the two successful adjacency with neighbor router, right? Okay, right. So show IP protocols. These are troubleshooting. Or verifying is also troubleshooting. Also can use. Yeah, if you find out, oh yeah, how come my agency not working? So you check, is it formed? Okay, so what kind of information I can get, right? So here you can see routing protocol is identified with the AS number 1, right? Of course, we just use one lah. In the real world, if you are large organization, right? Your network is large. ISP, bandwidth, telecommunication company, of course, that one will be replaced by number that's provided by IANA. Okay, so for our purpose, when we create our own one, a small one, no need lah, right? Because you know, we don't need to apply for the IANA AS number. Okay, so here you can see Eigrp and the AS number. Here you can see the router ID, right? This is for your own on your own router, right? And then the administrative distance and automatic summarization. Now this one actually, not sure is explained here or not. So I won't talk further on this automatically summarize. Maybe it will be touch on further chapters. Automatically summarize is a way for routers to share configuration, right? To share configuration. So that means one router um, can share its configuration. The other router can then apply the similar configuration. So don't worry about this now. Just know that this command does that. All right. So and next one will be number 5, routing information. This one is the what routing information sources. All the Ergrp routing source, right? To build the IP version 4 routing table. Meaning to say the other adjacent routers that supply the routing table information. They share their routing table information to you, to R1, right? So you can see here, yeah? See, routing information sources, from where you get the routing table info. Remember, as a router, R1 only knows directly connected networks to it. Okay, so other info inside its routing table get from where? From this one, other routing information sources, which is these two. Okay, the address of the other two routers. Okay. All right, so show IP routing, basically show the routing table. Okay, right. So this one we already discussed earlier on, right? So you can see this is highlighted is D. D is Ergrp, means the source is from Ergrp. Okay, right. Again, showing the highlighted one is from exchange information from other routers. Okay, using Eigrp. Right, and okay. Right. So again, another example. Right. So if you want to verify your Ergrp is working and the adjacency is formed, they will start exchanging information, right? So you should expect to see this entry in your own routing table. So this is R3, this is R2, this is R1, right? So you go to each of the router to find that out. All right. And I believe that's it. That's it for Ergrp. Any question so far?
So far, no.
Right. So the thing is, apart from the characteristics or Ergrp, you need to be able to. There's not many not many configuration for the Ergrp actually. Okay, I think it's only a few lines, but you need to remember it. In the SBA, you might be given a topology. You see, they will test you within one test all the configuration you've done. Okay, so you have to work slowly, step by step, right? So you have to, let's say they ask you to create VLANs on a switch, right? They ask you to configure the LAN first. So VLANs, based on the question, right? You create VLANs, you create trunk links, you connect it to routers. So then you have router on the stick, and then of course after you configure all the VLANs, all the LAN-based configuration, the switch-based, and then after you tested, verify all, then the next step will be configure the routers, right, until you complete your configuration, right? So my advice to you, now that you've seen the configuration for this one, copy paste the commands, the list of commands into, again, your digital notebook, right? So that you can have a copy. Okay, so this is the ERGRP configuration, right? I hope you've been keeping all of this like this, right, to prepare for SBA. So during SBA, you all very nicely, you already have a list of configuration to do what? To configure trunklink, to configure VLAN, to configure router and stick, configure ERGRP, something like that, right? So because it makes it easier for you to not to have to memorize everything, because you sort it out, you have all the commands there for yourself, and that means it's at your fingertips. You know how to use, but maybe you don't have to memorize. Okay, all right. So then you prepare lah. It helps you also when you're doing revision. All right. So please read through here. What are the topics we learned in this module? Okay, so let you guys go through this one. Huh? This is basically just a summary of what we have already learned. Okay, so that's it for this chapter. Okay, the next chapter that I want to cover is the security concepts. So I'm going to stop my recording first, right? So I can separate the recording later when I share. Then you can choose which one you want to view rather than have to check yourself, right? Okay, so are you guys okay to continue a different topic?
Mm,
You want a 5 minutes?
okay. 5 minutes.
5 minutes. I want to do my Lopez.
Okay, good. 5 minutes, yeah. Now it's 2:46, 2:51, right? 2:51.
Okay.
Hmm. All right, welcome back.
Yeah.
Right, so everybody back? Farah, yeah, back already. Okay, so change your pace, right, or change your topics, right? Before we are talking about routers and Eigrp and all other protocols, right? So this chapter we move on to a different topic. Okay, it's LAN security concepts. So um, we're going to look at what are the problems which we would encounter, right, and potential security issues lah, that can affect your LAN, local area network, right? So basically, you will think about security as part of your LAN configuration. Okay, so we want to identify first what are the security issues. Okay, and then we want to see what are the things that we can do. Okay, in order to prevent any security problems that we might have inside our local area network. Right. So again, I will record. Okay. Right. So here we just cover the LAN security concept. That means local area network. Let's see the topics that we're going to cover here. Right, so endpoint security, endpoint basically your host, right? You want to secure your network from the point of view at the edge where your network is connected to host, right? And this means attacker able to commandeer or take over one of the host machine, right? And then we'll use that host machine to attack your network or to get network information that you don't want anybody to know, right? So this is the topic here: endpoint security. Sometimes maybe not take over the existing host, but introduce a external host into your network and use the external host, because usually we also secure our endpoint by providing authentication, things like that, protect our host. But sometimes, you know the nature of network, we can plug in a different host, right? And then that host is not protected, and that host can access the network, therefore can introduce security issues, right? So one of the security part that we want to control is the access control, right? So authentication is part of access control. So how do we, in terms of network, right? We know already that from the OS level, you can provide OS level authentication, isn't it? But like I said, can bypass that. Some hackers can bypass that, but maybe because uh, no, the password simply not good enough for that particular host, or can bypass the entire host and then introduce their own unprotected host into the network. So we want to be able to have access control by authenticating LAN, your local network endpoints. Okay, and then we look at layer 2 security threats. The main security threats involving layer 2 PDUs like frames. Okay, okay, so we know that a lot of the authentication, apart from this one, then endpoints, the authentication at OS level is at application layer, right? But we know that our networks is formed of, if you look at OSI, is 7 layer. If you look at TCP/IP is only 4 layers. Means we protect on the upper layer, the application layer only. OS level authentication is at the topmost layer, right? Layer 7 or layer 4, in TCP/IP. So what about if the attack comes from layer 2? Okay, where our PDU is a frame, right? Okay, since our LAN is working on layer 2, yeah, the switch layer 2 devices. So what happens if the attack comes from layer 2? So basically, you can see that since it work way below from application layer, all your security level at the upper layer, the application layer, cannot protect, right? Layer 2. So if we want to protect layer 2, then what we do? So we identify first what are the security threat involving layer 2, right? And then at the layer 2, we know MAC address is being used, right? And we have a lot of services. In fact, the switch also is using MAC address, right? So we look at the MAC address table attack. Okay, the MAC address table exists inside the CPU. It's a way for the CPU, sorry, not CPU. The switch is the switch job to update the MAC address table, because the switch will use the MAC address table to forward frames based on the content of the MAC address table. So an attacker might attack the MAC address table in order to compromise your entire LAN, right? Then we look at other LAN attacks apart from the one we already mentioned. Right, so let's look at the first one, endpoint security. Right, so here basically is just an introduction to tell you that there are many articles already that inform us about network attacks or enterprise network attacks. Sometimes you hear like, oh, one of those big companies, all right, their network has been attacked, right, by hackers, right? So we listed out here the categories that a lot of these attacks categorized on. The first one is denial of service or distributed denial of service. Denial of service, basically, the main point of this kind of attack is to prevent services to legitimate users, right? So user usually access your services, they need your services, and your services is located inside your network. For example, servers or printing or whatever. Even your web server is actually part of your own network, right? And then you allow other public users to access it, perhaps. Or if it's intranet, then your own employee, but you allow remote connection, right? But a lot of the security threats actually are on the internet. So if you think about your web server, database server, whatever you expose to some users online, right? Then you know, they're vulnerable to attacks. So distributed of the denial of service comes from denial of service, and the words basically say what the attack is: to deny legitimate users of the service. How this happens is that they bombard your server with so many valid requests, right? That there's so many requests that your server basically cannot cope with it. When your server cannot cope with, overwhelmed by those requests, then your server just freeze, right? It means, and those valid requests actually not really wanting to use your service, but just to overwhelm your server. So distributed simply means that it's not coming from one machine, it's coming from many machines. It can be hundreds and thousands of them from all over the internet, right? And usually, why those machines attack your or request service from your server, thereby overwhelming your server, that the real user cannot access your service because simply there are too many requests, so the server cannot satisfy. Okay, and all the legitimate users also cannot get services. Simply means what they will see is 404 cannot access the service, right? Basically, hackers do not directly hack your machine because your machine probably is secure. So the attack less to other people. Okay. And since they are just normal everyday user computer, the security is not that, that tight, right? But of course, these computers, they do not have services, they do not have anything available to the hackers. But the hackers hack these machines to take over their machine to embed malware. And these malware are activated when the attacker wants to activate it. So it could be several months, it could be a whole year before, because once the malware is embedded in this type of machines, the malware just simply sleep inside the machine, not doing anything. So the owner of the machine have no idea that their machine already compromised. When the attacker wants to do this kind of attack, DDoS attack on a particular server, the attacker will then activate all this zombie fight machine. So the malware that has been sleeping now wakes up, receiving a command, then straight away sending requests over and over and over. So if you imagine the attacker has been amassing zombie machines, maybe in the thousands, hundreds of thousands machine, and they don't do it manually. They basically use a script or a program to do it automatically for them. Very similar to Google type of crawler, web crawler, to crawl all the available website. But Google just do it for indexing content so that you can search very quickly, right? They index it, they put in database, so then you access Google, they can search very fast, right? So that is legitimate use of a web crawler. But an attacker can also write their own web crawler, but this is to find vulnerability in the machine. If the software finds, and then they can just embed the malware inside, right? And once it's activated, all these machines wakes up, right, and attack, right? On basically, attack is a wrong word. I think it's start to send requests to a particular server, right? And because there are so many of these requests from so many zombified machines, then this distributed denial of service will happen, right? And then your server can't cope, thereby preventing legitimate service to legitimate users. Okay, right. So this is called DDoS attack. I think you guys ever heard of this before? This kind of attack? Yeah.
Oh, yeah.
Simply to deny service to other legitimate user. Then the second type is data breach. This one is because the attacker wants to access maybe information, okay, of value maybe to the attacker, to steal information, to get information, right? So this is called data breach attack, right? So this is usually more technical. This involve the attacker actually trying to penetrate through your defenses. Of course, you already have defenses, firewalls and things like that, right? But they will try to get inside your network, right? Once they're inside, and it could, I say technical is very difficult, but sometimes they can use social engineering. That means attack the most vulnerable, which is the human. Okay, they use social engineering, basically a con job, right? They trick the user. Okay, the most easy one is sending an email, unsolicited email to a user. User is not properly trained. They click on the email, click on the attachment, and then unknown to them, malware is inside. The malware creates a security hole, and the attacker cannot penetrate your system or start stealing information unknown to the user, right? So this is called data breach attack, because there's the security to your internal network is breached, and data can be stolen. All right, the third one I mentioned earlier is malware. Malware is can be a Trojan, right? Can be usually it's a Trojan. So because it pretends to be a valid software, right? And it drops out buried inside the supposedly legitimate software is a piece of code that create a compromise in your security, right? So what that malware does, either stealing data, right, or corrupting information, or encrypting your information, holding you hostage. Normally, that is called the ransomware. When they encrypt your data and say that, okay, so you're going to lose your data, we will delete it after five days if you don't give us such amount in in Bitcoin or something, right? Then you're whole hostage to your data. Your data is encrypted, you cannot access it, right? And if you want the password to access it, to decrypt it, then you have to give the money in form of cryptocurrency to the attacker, right? So you can see one of very popular or very famous examples of WannaCry malware, right? Okay, these are the things that we often hear. Okay, we often hear nowadays kind of attacks that happens, right? All right. So therefore, we want to avoid all these issues or these security issues, right? So just like in physical security, usually you put a security perimeter, right? A fence, a way to block any unwanted visitor from entering your secure area, right? So we think about our LAN as any users within the LAN is authenticated and allowed to use, then they can access, right? Anyone outside of the LAN not allowed to use or to view or to access the network are considered considered non-users, right? And they try to still use your network, means they are considered as attackers, right? So we employ a lot of network security device to protect our network. Okay, uh, the first one is called VPN. VPN is virtual private network. Private network basically is you're inside your own network. It's private because only certain people allowed access into the network, right? And before the keyword virtual is put in front of it, private network means you're physically using the network within the network itself. You're part of the network. You're inside the building. You're inside the the office. Okay, and the network is there. You can use the network, right? But sometimes, especially now with work from home, you want to allow, because you also link your private network to the internet. You put all the security perimeter. You protect. So basically prohibiting outside users from entering your network. But you want to allow, sometimes your employees want to access your private network, let's say from remote from home. So one way is to allow them access via authentication, right? But, excuse me, I drink first. The network traffic has to flow through the internet and is not always secure. One way to prohibit a third party from eavesdropping onto the conversation between your remote user and your local private network is to encrypt it, right? Excuse me. So one way to do that is to have a virtual VPN server and VPN client for your user. So basically, your user uses the VPN client to connect to your VPN server inside your network, and all the communication is encrypted between the two endpoints, right? So anybody trying to eavesdrop onto the packets or to the message flowing between the remote user and the local private network is encrypted lah. They cannot access lah. Right? Now, why we put virtual private network when we think we are describing this kind of communication is because it will seem to the user is transparent. To the user, if they use this kind of services, they feel like as if they are situated locally within the private network itself. There's no difference. Okay, if they log into their system in their own home or in their wherever, they can access as if they are local in the building, right? But it's actually virtual because they are not locally accessing the private network. They're actually remotely accessing. But the VPN software allows the security, the encryption of the communication. Of course, also the authentication is handled by the VPN also lah. As you connect the VPN client with your VPN server, you must be authenticated. But once you're authenticated, the communication happens, right? The traffic between the local private network with the remote user will be encrypted, right? Okay. So that's a virtual private network. And you can see this being used by a lot of organizations already. Right, so the next one, we consider his next generation firewall and GFW. Now this one is very quite powerful, right? And because it's no longer just blocking ports, because traditional firewall are just block ports. If you recall, in layer 4, transport layer, okay, one of the address that we need to provide is the port address. Port address is the way for us to identify the process running inside the host. If you have multiple network messages coming in, you need to direct the message to the correct application in layer 7. So because you can have multiple instances even for the same software, we need a better way to identify the process. So we use the port number. So so one way of the traditional firewall to block certain software from communicating is to block their ports. So you block all ports and only open application ports that is allowed. Okay, so maybe if you block, let's say you block IM, so it's IM ports. So that means instant messaging messages cannot then enter your network. Okay, you basically we know the OS, there is an OS level firewall, but we are talking about router is your edge of your network. Your router is the one that sees the packet coming into your network, right? So usually for organization, they put their firewall at the router themselves. So or just before the router. Okay, so it blocks any traffic belonging to certain ports. Okay, but that's the traditional way. Okay, now because there are some people are able to tunnel information within packets that is allowed. Let's say you open port number 80 for viewing web page, right? And then you can then a user can then embed or tunnel another application information within the packet for port 80, right? So then it bypass the port method, right? So now the next generation firewall goes beyond that. They actually open up the packet and checks the content, stateful packet inspection, right? So that's why we have stateful packet inspection. Of course, this will be you have to use combination lah, because sometimes packet inspection doesn't work if your packet is encrypted, right? But some firewall is clever enough if it's encrypted not in a proper way. That means it's encrypted because you need to hide certain things, that it will still block, right? Application visibility control, next generation intrusion prevention system. This intrusion prevention system is sometimes linked up to a machine learning software. Machine learning software will detect whether, because the way the traffic is working, yeah, it will identify, oh, this kind of traffic is usually intrusion traffic. So the machine learning software, it means it can learn and it can also identify, right? So this is the next generation intrusion prevention system. Usually is applied with some kind of machine learning or AI software, all right, to detect, right? Advanced malware protection and URL filtering. URL filtering basically simply block because you know you need to access a lot of the website, but some website you don't to allow. So you use URL filtering. You filter addresses that is not on the whitelist. So blacklisted URL would be blocked. So this is one of the feature for our own firewall. Okay, if you're in the college and you're using our college network, so certain if you try to access certain URL, which is in the blacklisted URL, then you'll see that a warning message comes up instead. Okay. All right. So to a certain degree, Malaysia's ISP also implement this kind of protection, right? Then you have the network access control, NAC, and this include authentication, authorization, and accounting, right? And this one to access usage of the network to control the access to your network, right? So it might be incorporated in appliance. Appliance simply means a device, that can manage access policies. So you centralize all this authentication, this triple A, authentication, authorization, accounting is centralized into a server. Basically, you can put it onto a router or on a larger network. Okay, where you have many routers, then you can have a centralized server. Okay, centralized server that sole job is to house this network access control, right? Okay, right. So these are some of the network security devices that you might find in a network in order to provide a safe network environment. All right. So endpoint protection. Mentioned earlier on about endpoint being host. So you can see could be laptops, could be desktops, servers, and IP phones, right? As well as for bring your own device, because nowadays that's the trend. Bring your own device. Meaning to say that some employees prefer to use their own device. They have the device that they like, and from the employee's point of view, yeah, they don't have to provide. That means they save their budget, okay. So you can allow you to use your own devices because that's what you like to use. And then for us, well, we're happy because we don't have to spend money to buy you another device. You prefer to use yours, okay, it's fine. But the thing is, less control will be available to this kind of end devices. For example, bring your own device, because this is personal computer, personal devices, right? So it might not be as secure as a company computer where it comes under jurisdiction of the company's IT department, right? There's a standardized way to secure companies end devices, whereas your own device may the restriction may not be so tight, right? So because of all this, yeah, endpoints are susceptible. That means they are more prone to malware related attacks, right? Malware software, okay, that's embedded with with some part of attackers module that can do whatever they want lah. Like I say, malware sometimes can be Trojan. They pretend to be something useful, but then unknown to you, it has some features inside that you can't see that compromise your security, right? And usually they come through email. Like this one is part of social engineering. They know what is the latest viral, maybe funny GIF or funny whatever. Then of course nobody will think twice of, oh, that's a cute cat picture. So you click. In fact, it's not a cat picture. It's actually an exe, and it's already, when you execute, it's already a resident in your memory, and it's already started. If it has a worm embedded inside the attachment, then it's already tried to access other parts of your network, right? Or sometimes when you're doing web browsing, that's why we have URL filters, because sometimes you go to a web browser that has the malware embedded inside it. The moment you access it, right? It especially for non-up-to-date browsers where they already have zero-day security issues, right, and can be exploited. Okay, and if the organization doesn't have a policy of keep patching the web browsers to the latest version due to vulnerabilities, then some websites make use of these vulnerabilities to attack the user's machine, right? So just web browsing can lead you to accidentally downloading malware, right? So again, very very careful. Okay, sometimes it can reload and ask you a certain question, but actually it's a permission to download something. And unknown to you, behind the scene, it download, and then you can, when you look at it, it's like it's very interesting kind of, maybe it pretends to be a video, it pretends to be something, right? Then you double click and it's running. All right. Okay, so endpoints based on OS level security features lah. So traditional host-based security features such as you install antivirus, anti-malware. So for Windows 10, maybe we have Windows Defender, right? And host-based firewalls means your OS-based firewall, right? We know that all Windows will activate their firewalls, right? And maybe perhaps if you install a more capable antivirus or those security software, they might even have host-based intrusion prevention systems, right? Okay, so it says here endpoints today are best protected by a combination of all these things, NEC, anti-malware software, email security appliance, a web security appliance. So this is what Windows Defender, you can see when you open up Windows Defender, you can see it protects you against a host of what lah. Let me just show you what it means, what I mean. Right, so can't access. Oops. Okay. All right. So all settings. And then security. Somehow my systems are a bit slow down. Sorry about that. Windows security, I can see it. It's so slow. Right. So while it's loading, so what I was talking about is that nowadays it's not just antivirus. It's got antivirus, anti-malware, and then combined with your firewall. Um, it's got now that because of the different types of vulnerability that's already happening, right? That attacks Windows. For example, attack Windows is an example. Then, of course, um, the OS developers like Microsoft have to also be aware of this, and they normally install. So I'm looking at the Windows security. Okay, Windows security has virus and threat protection, account protection, firewall and network protection, app and browser control, device security, device performance and health, right? And even family options where you can control what your family can access. So all this, right? All this now standard, pretty standard. One thing I have to mention also is that now with Windows 11, they actually need TPM, which is a hardware-based security, right? This is built into your BIOS working with your CPU. And that's why Microsoft really serious about this kind of protection because they want to avoid where Windows been attacked um, with malwares, with ransomware like before, right? Okay, so I think we reached 3:30, so I'm gonna stop here, right? And then continue again lah. So we cannot finish until like this chapter lah. So we'll continue next week lah, right? We'll try to cover up this one. Let me just stop recording first, right? And yeah, we just reach endpoint protection. Right. Okay. All right. So I've already updated the. I already put in the our calendar to invite you guys for this this evening. This evening, your midterm test. So the meet will be open starting from 5 o'clock and then completes at 7 o'clock. So we had a discussion with all the other lecturers and CC. We agreed to extend the time by another 15 minutes. So you have basically 1 hour 15 minutes to complete your test, right? So let me just bring that up. And let me just very quickly get it. Yeah, this one. Right, so it's adjusted. I've already I will update the one in the Google Classroom stream now, but for the midterm test, we're going to use our current Google Classroom where you did your dry run, yeah. Okay, and you'll be scheduled to open later. If you don't see it yet, it will be scheduled to open later. So the 5 to 5:05, you log into the Meet, right? And then 5:05 to 5:10, your answer template will be open, so you can start filling up the details on your answer template, right? And then 5:10 to 5:15, question paper will be released, and then at 5:15 you will start answering until 6:30. Okay, so from 5:15 to 6:30, right? And then that will be around 1 hour 15 minutes, right? 1 hour 15 minutes. And then 6:30 to 6:45, you're given 15 minutes between 6:30 and 6:45 for submission time, just like what we do in our dry run. So the only difference is that we extend by 15 minutes your time to answer the question, right? And if you submit late between 6:45 to 7 o'clock, your marks will be deducted by 5 marks, right? 5 marks will be deducted. And midterm tests will be 0 if you submit beyond 7 o'clock. Okay, beyond 7 o'clock at night, your marks will be downgraded to 0. Okay, so this is basically same as what we've discussed in dry run. Okay, so between 6:30 to 6:45 is your time to submit. Please submit during that time. All right. So this tutorial session, okay, I don't mind if you want to use it for revision, right? Revision. Let me remind you what you need to do. To study. Okay, so hang on. Okay, so we already mentioned that up to STP, right? So you should study collision and broadcast domain, right? Okay, and just go through back your tutorial, okay? Tutorial, and look at the questions. Okay, those are some simple questions from past year, and also and it's a very similar kind of question, right? So please study your collision domain and broadcast domain, okay? And the study about switches, okay? So study about switches, the forwarding, switches forwarding, and I think you need to do VLAN, to study VLAN also. VLAN is part of the test, VLAN, right? And you need to learn the router on the stick is part of the coverage, right? Router on the stick, right? And the spanning tree protocol, right? Especially what we learned already in the tutorial. Okay, how you need to find the root bridge, root ports, destination ports, and identify block ports. Okay, all right. So why don't we use this 1 hour to do revision? You go how you do it. You go through back all the tutorials we did, and make sure you understand. Although it's already answered, right? You can try to look through it and try to do, okay, find out how the answer is done. Okay, some of the question, because it's allocated to different person, right? Especially those question not allocated to you, have a look at it and see whether you understand the question and how it's answered, right? So while you're doing that, okay, go through all the up to STP, okay, up to STP. And if you have any question about the tutorial, especially those that was not allocated to you, someone else do it, okay? So you should focus on that, because I think the one that you have answered, you probably know how to answer, but those not allocated to you, maybe because it's someone else answer, maybe you're not too sure how it's done. Look at that one and try to don't look at the answer first, try to answer yourself, right? And then while trying to answer, if you don't understand certain things, you ask me, right? So I believe that will be better for us for this tutorial to prepare for the midterm test later. Okay, is that okay, everyone? Is that okay with you?
Okay.
Yeah, do revision. Yeah, go through as what I mentioned earlier on, all the chapters until STP. Okay, I highlighted uh, collision and broadcast domain. You need to know the VLAN. Okay, and the what did I say just now? VLAN, router on the stick, right? Inter VLAN routing. and STP. For STP, make sure you know how to find, you still know how to find. This is open book, so it's okay, right? If you don't memorize, but you should need to know how to do it, okay? Finding out the root bridge, the root ports, designated ports, and then finally block ports, okay? All right. I will be monitoring that. So if you are doing and then you're not sure, you let me know. You can either just simply unmute and ask me the question straight, or you can message here. I open the message for you. All right.
The structure mostly same as the tutorials.
Yeah, very similar to the tutorial.
Yeah.
Okay. And the spirit of the question is like the tutorial. Okay. So basically, when you look at the broadcast or collision domains, right? The question is very similar. Okay.
Okay.
Okay. Oh yeah. So should we switch over to the Meet for tutorial? We switch over to the Meet tutorial. Yeah. Tutorial Meet. Sorry. All right.
Okay.
Okay, okay.
See you there.
Okay.
Okay, Noel. Hang on, let me get access to it first. Okay, so let me see. Tutorial participation, tutorial 4, SCP, question 2.
Yeah.
Have a look first.
Question 4. This one.
Question 2, is it?
Yeah, question
Spanning
2,
tree
and then
protocol.
inside the question 2, in question Roman numeral number 4.
Okay, hang on. Question 4. Let me just share my screen. Number 4, non-designated port.
Yeah.
Right?
I confused.
Okay, so I try to remember first. Okay, let's see. Okay, I remember this. Okay, root bridge switch A because it has the
lowest MAC address.
Yeah, lowest MAC address because priority are the same, right? So 001, so that wins. So that is the root bridge, right? And then root port on the non-root bridge. Non-root bridge we can identify as the switch B, C, and D, correct? Okay, so let's see.
Yeah.
For switch B, it's the root port will be the ones that's leading to the root bridge. So this one, G01, correct. So switch D is F024, correct. Switch C, because we have two, right? For switch C, right? Okay, so then we have to compete, right? And then we compete between the switch D and switch B. Is that correct? And the winner is switch C.
Switch D.
Yeah, switch D, because
The MAC address.
MAC address again is lower than 002 compared to 00D0 because priority is the same. Okay, so that means G01 becomes their root. So if that is root, the other one becomes well, compare between the switch B and switch C, F02, G02, which one is designated port lah. So and the one designated port, the other one becomes block port. Let's see, designated port on root bridge, switch B. B would be F2 and F21. F2, F21, F2, F21. These two. How do we get that already?
Because it's receiving, right? Receiving end of the root.
Yeah.
I mean,
It's receiving. But between F21 and the other one, F21, switch B and switch D, why this one wins?
because switch C prefer switch D, right? To it goes to switch D, then it goes to switch A.
From switch. Let's see. Number 4, number 3. This is question 2, is it?
Yeah. I confused on the part 4.
Okay, so the answer, wait, number 3, designated port. We forgot to mention A also designated port.
Isn't it the root port?
Yeah, no, this one, G01 and
receiving.
F023. So you have to add in the answer.
But in
So
the it says in the non-root bridge or not so, but A.
oh
but
yeah,
A is
non-root bridge. Okay. Non-root bridge. Correct. That is a root bridge. So we only consider the other. Sorry. Yeah. So B F2 and F21. Do you guys recall why we choose F21 on switch B rather than F21 on switch D? Why this one rather than that one? It's because
if F024 fails, he used the F21. Right?
yeah, but why F21 not designated? Why F21B is designated rather than F21
Because
on D? That
is it the speed?
Yeah, why this one? I
Uh,
forgot. Switch B F21 ba. Why this one is designated? This one blocked. Do you remember?
Why again?
Yeah, because we have to choose, right?
Oh yeah, need to choose.
Oh yeah,
which one.
why we choose that already? Yeah.
I think I forgot. Based on logic, should be D or
No. We just want to know why. It's correct already, but why? This F2 at G1 is correct already because it's receive traffic. So F2 on switch B and G1 on switch D is correct already, as what mentioned by Noel, because it's receiving traffic, right? So designated port lah. Okay, it's receiving traffic from switch C, so designated port. And for non-designated port on non-root bridge, non-designated means block lah, right? So this one we know G02 is block port. Non-designated means block port.
Oh, I thought
No,
non-designated means root port.
Yeah, because the opposite of designated is non-designated, but this is the old keyword lah, but still can be used.
if one place is not designated, if the other place is designated.
Yes. So the non-designated, also known as block port.
Oh, I see.
It's block
Is
port.
it the yellow? Is it the yellow color? Just kidding. No.
Sorry, what did you say?
Oh, the color. There's a color.
Yeah. This means it's blocked. Yeah, from here you see it's blocked. But we have to understand why it's blocked. This one we understand why G02 and not G01 is blocked is because the winning is this one, switch D. Switch D has same priority, but switch D has lower MAC address, whereas switch B has higher. So G01 wins. It becomes how come? Hang on, switch C. This is root port lah, kan?
Yeah.
G01 is root port. Yeah. This root port, this designated. So this one lose. So this one becomes block port. This one becomes designated because it receives traffic. So now, question is, why this F021 on switch D is blocked rather than this one on switch B? This one is blocked. This one should be designated. But why is this win? I forgot. Do you guys remember not?
Oh, isn't that the shortest way for the switch B? If not from the
correct. Because of this one, right?
Yeah, that's one
This
way,
is
and
gig.
then the other way is the shortest way.
This is gig, and that's why, right? And this one is gig, and this is F. This is F, right? F. So between this and this one is faster. So this one is blocked. This and this This one is faster compared to this because it's this FG, so this is slower. Oh, I see. Okay, Kelvin, thank you. Is that Kelvin just now answer?
Yeah.
Okay, okay. So Noel, is that okay with you?
Okay.
When we look back here, how come this one is preferred than this? Is because this is gigabit connection. This one is fast Ethernet. Although this is gigabit, this is fast Ethernet. It's always fall down to the slowest part. So although this is gig, this one will become fast Ethernet. So this one is slower than this. So this one wins. Between this one and this one, for this, right? You prefer this one, right? So this is gig. This one is fast Ethernet. So fast Ethernet is blocked. This part. This one is enabled. So that's designated. That becomes blocked. That's designated. That's become blocked. Yeah.
No. Okay.
Okay. All right. Thank you, Kelvin. Farah, were you following our conversation?
Yeah, I'm
Yeah.
at here the tutorial for.
Okay, so you are following our conversation here, how to distinguish between designated and non-designated or block port, right? So the step for STP, find the root bridge. Root bridge, you look at priority. If all equal, then look for the value of MAC. The lowest MAC address will win. So in this case, switch A wins. So switch A root bridge. Okay, on the switch A root bridge, all its interface become designated port, right? And then, of course, when this is designated, the opposite become root bridge. Root port. So this G01 on switch B and switch D F24 root port. Okay, facing towards the root bridge. So that means this and this candidate, this one this and this candidate, G02 on switch C and G01 on switch C, candidate root port. Okay. Which that means this one, the opposite one is designated. Okay, receiving traffic, designated. So this and this, okay, designated port. So between this and this, only one is should be a root port. So this, we choose this one because this is faster compared to this root. So this become non-designated port. This one becomes block port lah. Right? And between this and this, right? Which one becomes designated port is the one on the faster route lah, faster path. So this is the faster path compared to this. And then this one become designated, the other one become non-designated port. Right? So what happens if this is the same? When the path is equal, we check what? What's the
port number?
The port
MAC.
ID, right? Which is what? So if let's say this path and this path is equal cost, so we look at port ID. Is it?
Yeah.
The higher port ID, the better, right?
Oh, is it higher or lower? Higher, is it?
Just ask double check on it.
I think a lot of times it's always the lower one. Let me just double check lah. I'll double check for you guys. STP. STP. Okay, just check. Yeah. Oh, yeah. Oh. The root part cost. Remember, 100 megabits per second. The fast Ethernet is 19. 1 gigabits per second is 4. The cost. Just now we talk about cost. All right, so when it's the same, when the same means they will have the yeah, lowest sender port priority. Elect a root port for multiple equal cost path. So I'm just gonna change over the sharing to the other one, so you can see where on your okay, so you can see on the screen, right? Right. So check the sender port priority. Okay. So S4 has two equal cost path. Then this is what I was talking about. If the cost path to the root bridge is the same, right? And both ports are connected to the same switch, the sender BID is equal. So that means if the equal cost path, you check the sender BID first, right? Only in this situation where you have the two link connecting switches, will the sender BID be equal? In your example, right? The sender's BID is not the same, so there will be a winner, right? Hang on. Port priority. The default port priority is 128. It's one actually given, but in our, I think in our diagram in the tutorial, since the differentiation is done by the cost path, so they don't bother give us the port priority, right? Should be the port priority to be looked at. Okay.
Okay.
Yeah. Okay. Remember, you guys need to know how to do the router and stick.
Yeah.
Okay, router and stick, you know how to do, basically trunk link from the switch to the router, and then the router creates sub interface for each VLAN, right?
The one that got the encapsulation .1Q, right?
Yes, that one with a .1Q encapsulation. Okay, that's called inter-VLAN routing to allow traffic to flow between different VLAN. Let's say you have VLAN 10, you have VLAN 20. Okay, so without the router on the stick, traffic only flow within each individual VLAN. So host with VLAN 10 only talks to VLAN 10 host. Similar with VLAN 20. So if you want the host from VLAN 10 to be able to talk to another host in a different VLAN, let's say VLAN 20, you have to configure router on the stick, right? And then configuring router on the stick, that means the link, the single link will be trunk link, and then on the router side, you have to create sub interface on that interface where the link from the switch, okay, arrive here. And then each sub interface you have to configure for the particular VLAN. Okay, so one sub interface will be for VLAN 10. Let's say you have two, right? One sub interface for VLAN 10, another for VLAN 20. Then you enable routing. Then then the two can talk to each other already lah, via the router and the stick configuration. All right.
So if the switch to router, what is the switch mode? It's
The
access, right?
switch to router for the inter-VLAN.
Yeah.
Yeah. Trunk link too. It
Yeah,
has to be
trunk.
trunk link. Yeah, because you only have one link, right? And then you allow multiple VLANs traffic to pass through the single link. So that means that link has to be trunk link.
Oh,
That means on the switch side is trunk port. Access port is only for ports attaching from the switch to a host. Then the port on the switch is called access port. That means you set access mode lah, right? Because it's accessing from host to switch. But whenever it's switch to switch or switch to router, because you want to enable multiple VLANs traffic in a single link, then you have to configure trunk link. That means the port on the switch will be trunk ports.
oh, okay.
Yeah. Only up to STP, no ether channel. No coverage on ether channel. Only up to STP. Also recall that which device will segment collision domain?
Yeah, recall.
Switch, right? Switch
Sorry,
will segment the network into collision domain. Router segment the network to broadcast domain, correct?
Yeah.
Yeah. So how about hub? Can hub segment into collision domain?
No.
No, because hub is on layer 1. Hub is layer 1 device, so it does not, that means it does not segment collision domain, right? It's also half duplex. So definitely hub will cause collision because hub is a half duplex. Whenever you see half duplex device, it is always involved in collision. Basically, receive and transmit can only work half duplex. Receive and transmit of messages can occur at the same time, right? That's why it's part of the collision domain. It cannot segregate the domain, right? But switch different. Switch has a physical wire, multiple physical wire. The Ethernet cable. So that means you can allocate two wires for transmit, 2 wires for receive. So they are separate wires. So that means they never will collide. Okay, so that's why switch can segment network into different collision domain. Okay, and hub is half duplex, means it cannot. So hub cannot segregate lah. Hub will be part of the collision domain. All right, so I think let me just grab an example. So it's under tutorial 1, I think. Let me just share. Yeah, so here, where is it? Collision domain comes under which one? Here. So you can see the answer here given. You can see this is switch. So that's broadcast. Let me see collision. Here collision domain, right? So you can see that when you see the switch can segregate. That means it can separate network into collision domain. So here, you see, right? The switch can divide into, but look at hub. Hub cannot. So from this point of the switch all the way, because this one hub, right? All the way here will be collision domain. Here the same. Hub here. So all the way here will be collision domain. Right? So be careful when if you draw the circle, okay, don't overlap. Ngam the edge of the media like this, cantik. Okay.
Can freehand?
Can, as long as you draw the circle cantik lah, you know. Ngam the edge of the circle reach the edge of the media, right? Like this is not so perfect. When you see that, this one is like halfway through the media. If this one can be extended to, you know, like closer to like that edge, cantik lah, right? Like this one is ngam. Okay, ngam there like that, collision domain. Okay, whenever you see hub, the hub cannot segregate, so you cannot draw here the whole thing from the switch or encompassing the hub. See, encompassing the hub. Try not to overlap like this, the circle overlap onto the device. Okay, so that's collision. Broadcast, basically, you can see here example Faraday. Okay, ngam also ngam. This one cantik lah, right? So when it comes to broadcast, the segmentation of the network is via router. You look at the router and then you circle that broadcast, right? When you look at the collision domain, look at switch. Okay, ignore hubs. So when there's hub like this, ignore. Just circle the entire thing, right? Because hub layer 1 cannot in this half duplex cannot segregate network into collision domain, right? But primarily it's like based on this. But don't forget also between routers, that is its own collision domain also. Okay, is that all right, everyone?
Yeah.
Okay. And then what else should I touch on? I think inter-VLAN lah. Inter-VLAN. So I was talking about this one is legacy, 2 means only support 2 VLAN. Legacy 1, if you want to support 3 VLAN, then you have to have 3 links. 2 VLANs, 2 links. Okay, that's not very good. So what we want is a better way to do it, which is here is still legacy. Is it router and inter-VLAN routing? This one is still there's no example here on this one is inter-VLAN using multi-layer switch. Is there any this one is an example of router and a stick, only one link going to the router. Okay, so that one link must be trunk. Why? Because it allows multiple VLANs to travel through this link. So in that means we have to create a trunk between here and here. Okay.
Oh.
Yeah, and then
yeah.
Sorry. Go ahead.
Actually, I want to talk about the question 4, but no man later.
Question 4 where? This one?
Yeah. So here.
This one because you have 2. This is the legacy one.
Legacy. Also must be access.
Yeah, because one link, one VLAN.
I see. Okay.
And legacy because not scalable. You cannot expand your network. If you want another VLAN to support, then you must provide another link, physical link. So here 2 links means 2 VLAN only. Okay, this is the legacy way to do. Okay, the best way to do is this one. but then you have to buy this multi-layer switch. Yeah. So the halfway mode is this one. If you cannot buy another multi-layer switch, you already have a router. Okay. Just do router and a stick. So only one link, but this link is trunk link. So even if you add more VLANs, because this is trunk, it can support multiple VLANs traffic. Only thing to remember is on this interface on the router, you have to create one sub interface per VLAN you want to support. Per VLAN, yeah. So this is trunk port lah, trunk port on the switch.
Okay.
Okay. Right. So later on, you guys already received my invitation, right, for the meet?
Yeah.
Yeah. So we will have around now is 4:30. I will start at 5. So you have half an hour. You guys can take a quick rest lah first before we have the test, right? So
Okay.
Join at 5. As I mentioned, right? Let me just share my screen. Oops, not the meet. Oh, yeah. Share this tab. Okay, so join at 5, right? And then at 5:05 to 5:10, your answer template will be released to you. Okay, you can start filling up the details lah, just like before, right? And then question paper to release between 5:10 to 5:15. Once you get it, you can start answering lah. You're given extra 15 minutes. This one, we have the discussion lah, right? And then at 6:30, you complete, and submission time is 15 minutes. Okay, submit as before in our trial run. Two format, Google Doc format and PDF format. Okay.
Okay.
That's the instruction. That's the only instruction. All right. Any other questions before we end our tutorial session this afternoon?
So far, no.
No.
I don't know. Kelvin?
No.
No. All right. Okay. So I think that's it for now. I'll meet you guys in our midterm test meet at 5 o'clock.
Okay.
5 o'clock later. Okay. I'll see you guys then. All right. See you then.